The cosmos holds secrets that defy our wildest dreams. We are about to journey through 25 of the most bizarre cosmic events ever recorded, a collection of mysteries that stretch the limits of science and imagination. By the end, you will witness a universe far stranger and more wonderful than any fiction. We will encounter a signal so shocking it was literally named the Wow, and a star that dims in ways no one can fully explain. What is the most astonishing truth you believe is still waiting for us in the dark? That journey begins with a single, fleeting whisper from the void. In the late summer of 1977, a radio telescope at Ohio State University known as the Big Ear was silently scanning the heavens, methodically listening for any hint of order in the cosmic static. On August 15th, it heard something extraordinary. For exactly 72 seconds, a powerful, focused beam of radio waves slammed into the receiver from the direction of the constellation Sagittarius. The signal was not a repeating pattern or a complex message, but a pure, unwavering tone at a specific frequency that is naturally quiet in the universe, a frequency scientists had identified as a potential channel for interstellar communication. Its intensity spiked off the charts, appearing and then vanishing completely, never to be heard again. When researcher Jerry Amon reviewed the computer printout days later, he was so stunned by the sheer power and perfect profile of the signal that he circled the alphanumeric code representing its strength and simply wrote "Wow" in the margin. That single word of astonished handwriting gave the enigma its immortal name, the Wow signal. For decades, that solitary data point has fueled a profound debate. Could it have been a natural cosmic event, some unknown astrophysical burp, perhaps a reflection from a passing satellite or a piece of space debris? Yet every proposed natural or human-made explanation has struggled to fully account for its precise characteristics and its singular, never-repeated nature. This leaves the haunting, unanswerable possibility hanging in the air that for 1 minute and 12 seconds in 1977, we may have briefly intercepted a beacon, a cosmic shout that was never meant for us. It was a mystery that arrived, announced itself with shocking clarity, and then retreated back into the silence from which it came, teaching us that sometimes the most profound evidence is not a sustained conversation, but a single, unforgettable hello. That solitary, unanswered hello from the cosmos showed us that the universe is capable of profound surprises. But what if the next great mystery was not a fleeting signal, but a star that simply refuses to behave like a star should? In the constellation Cygnus, over 1,000 light-years away, there is a star that has become one of the most puzzling objects in modern astronomy. Catalogued as KIC 8462852, it is better known as Tabby's star, named for the astronomer Tabitha Boyajian, who led the team that first sounded the alarm about its bizarre nature. While scanning data from the Kepler Space Telescope, which was designed to hunt for planets by detecting the tiny, regular dips in starlight caused by an orbiting world passing in front, scientists found something utterly different. Tabby's star does not dim in a gentle, predictable rhythm. Instead, it experiences dramatic, chaotic plunges in brightness. These are not the slight fades of a planet, but colossal drops of up to 22% of its total light. And these dips are irregular, sometimes lasting for days, sometimes for weeks, with no discernible pattern at all. It is as if something enormous and shapeless is drifting haphazardly between us and the star, blocking its light in a way that defies all conventional explanation. The strangeness was so profound that one of the first hypotheses to capture the public imagination was as breathtaking as it was radical. Could these be signs of an alien megastructure? The idea, popularized as a Dyson swarm, suggests a vast collection of solar panels or habitats built by an advanced civilization to harness the star's energy, their uneven arrangement causing the bizarre, unpredictable shadows. While astronomers treat this as a last resort possibility, Its very consideration highlights how deeply unusual the data truly is. Of course, science seeks natural answers first. The leading theories propose a massive, chaotic swarm of comets, perhaps stirred up by a passing star, or a thick cloud of interstellar dust and debris circling the star in a highly irregular ring. Yet each explanation faces challenges. A comet swarm of the necessary scale seems improbably vast, and certain dust properties do not perfectly match the observed light patterns. Years of intense observation have only deepened the mystery, with the star even showing a long-term, gradual dimming over the past century. Tabby's star remains an open case file, a cosmic detective story where every clue leads to more questions. It teaches us that sometimes the universe presents not a clear signal, but a persistent, maddening anomaly, a celestial beacon that flickers in a code we have not yet learned to read. Tabby's star is a solitary enigma, a single point of light behaving badly. But our next mystery is not about a lone star, it is about the motion of our entire galaxy and everything around it. We are caught in a silent, unstoppable river of galaxies, all flowing toward a single point in the dark. Astronomers call this the Great Attractor, a gravitational anomaly of terrifying power. Picture the Milky Way not as an island, but as a raft caught in a vast cosmic current. We are moving through space at over 2 million kilometers per hour, and it is not just us. Thousands of other galaxies in our local region are all being pulled in the same direction, toward a specific spot in the constellation Centaurus. The force required to orchestrate this immense, coordinated motion is almost beyond comprehension. It hints at something colossal hidden in the intergalactic void, a gravitational anchor so massive it can tug on entire galaxies. Yet for decades, this titan remained invisible. The Great Attractor lies directly behind the plane of our own Milky Way, a region astronomers call the Zone of Avoidance. This is the dusty, star-choked central disk of our galaxy, and it acts like a thick cosmic fog bank, blocking our view of the universe beyond an optical light. It is the ultimate cosmic irony that the most powerful unseen force in our neighborhood is hidden behind the brilliant clutter of our own celestial home. To peer through this veil, scientists had to use different eyes. They turned to radio, X-ray, and infrared telescopes, wavelengths that can slice through the dust. Slowly, a clearer picture has emerged. The Great Attractor is not a single, monstrous object like a black hole. Instead, it appears to be the heart of an unimaginably dense concentration of mass, likely centered on the Norma cluster, a rich gathering of galaxies. But even that cluster alone does not seem heavy enough to account for all the gravitational pull we feel. The leading theory is that we are being drawn toward a supercluster, a node in the cosmic web where filaments of galaxies meet, woven together by immense strands of dark matter. This invisible scaffolding of the universe concentrates normal matter, galaxies, and gas into these dense knots of gravity. We are not falling into a pit, but sliding down a slope in the fabric of space-time itself, toward the deepest valley in our corner of the cosmos. This revelation transforms our place in the universe. We are not merely orbiting the center of our galaxy. We are passengers on a much grander voyage, part of a flock of galaxies migrating across billions of light years, drawn by a shadowy giant we are only just beginning to map. The Great Attractor reminds us that the most powerful forces are often the ones we cannot directly see, their presence revealed only by the irresistible motion of everything around them. That immense, unseen river of gravity pulls us through the cosmos, but sometimes the universe does not pull, it shouts. Across unimaginable distances, it sends out sudden, deafening blasts of pure energy that vanish in less time than it takes to blink. These are fast radio bursts, and they are among the most explosive and puzzling signals ever detected. An FRB is exactly what its name suggests, a burst of radio waves that arrives from far beyond our galaxy, packing more energy in 1,000th of a second than our sun emits in 3 entire days. Then, just as suddenly as it appeared, it is gone, leaving astronomers scrambling to understand what they just witnessed. For years, every single FRB was a unique event, a cosmic flash in the pan that appeared once in a specific patch of sky and never repeated. This made them nearly impossible to study, like trying to solve a murder with only a single, blurry photograph of the crime scene. The theories were as dramatic as the bursts themselves, ranging from the cataclysmic final screams of stars being shredded by black holes to the violent mergers of incredibly dense neutron stars. Then everything changed. In 2016, astronomers confirmed that one particular burst, catalogued as FRB 121102, was doing something extraordinary. It was repeating. Not on a schedule, but sporadically, firing off multiple intense flashes over time from the same location in a tiny dwarf galaxy 3 billion light-years away. This single discovery shattered the idea that all FRBs were one-time cataclysms. If the source could survive to burst again, it had to be powered by something that could fire repeatedly, something that was not destroyed in the process. The hunt for an explanation narrowed. The prime suspect today is a type of stellar corpse called a magnetar. Imagine a neutron star, the crushed core of a giant star, but with a magnetic field so powerful it is a quadrillion times stronger than Earth. These cosmic magnets can experience starquakes, violent ruptures on their surfaces that crackle with energy, potentially launching these brilliant radio screams across the universe. The repeating FRB seems to fit this model well, like a temperamental, hypermagnetic lighthouse flickering unpredictably in the deep. Yet the story may have even stranger chapters. Some scientists speculate that certain unusual, one-off bursts could still be signatures of more exotic events, perhaps even the birth of a new black hole or the collision of cosmic strings, theoretical defects in the fabric of space-time itself. Every new FRB detected adds a piece to the puzzle, but the full picture remains elusive. These brilliant, fleeting screams in the radio dark show us a universe that is not just vast and quiet, but also violently energetic, capable of concentrating the power of ages into a moment so brief we can barely catch it. The universe screams with energy in fleeting radio bursts, but its deepest whispers may come from the quietest places of all. There is a paradox hiding in the heart of black holes, a puzzle so fundamental it threatens to unravel our understanding of reality itself. It is called the black hole information paradox, and it began with a revolutionary idea from Stephen Hawking. He showed us that black holes are not truly eternal. Through a subtle quantum process at their very edges, they can slowly leak energy, evaporating particle by particle over cosmic timescales. This emission is what we call Hawking radiation. It is a faint thermal glow, and according to Hawking's original math, this radiation is random, pure noise. It carries no information about what fell into the black hole. This creates an impossible conflict. In the quantum world, information is sacred. The rules say it can never be truly destroyed, only scrambled or rearranged. Think of it like burning a book. The pages turn to ash and smoke, seemingly erasing the story. But in principle, if you could collect every single ash particle, every trace of gas, and account for the exact heat and light released, you could theoretically reconstruct the entire book. The information still exists in the universe, just in a vastly more complicated form. A black hole, according to Hawking's early work, does something worse than burning the book. It seems to drop the book into a bottomless pit, and then the pit itself eventually vanishes into thin air, leaving behind only a featureless puff of thermal smoke. The information is not scrambled, it is permanently deleted from existence. This is the paradox, Einstein's theory of general relativity, which describes black holes as simple, smooth pits in spacetime, says the information is gone forever. Quantum mechanics, the rules of the very small, says that is absolutely forbidden. Both theories cannot be correct. For decades, physicists have wrestled with this. One leading idea suggests the information does escape, but not in the way we thought. Perhaps the Hawking radiation is not random after all. Maybe it is subtly encoded like a hologram with all the data about what fell in imprinted on the radiation leaving the event horizon. Another radical proposal is that black holes do not have a true point-like singularity at their center, but instead that matter is preserved at a final, dense wall, a firewall of quantum fury that prevents information loss. The paradox forces us to confront the fact that our two most successful theories of the universe are fundamentally incompatible at this extreme edge. Solving it may require a new theory of quantum gravity, a framework that can describe both the warping of space-time and the rules of quantum information. This is not just an academic debate, it is a struggle to understand whether the universe keeps a perfect, unbreakable record of its own history, or if some chapters can be torn out and lost forever in the dark. The paradox of lost information confronts us with the deepest laws of physics, but sometimes the universe leaves evidence of its past violence written across the sky in light we cannot see. Emanating from the very heart of our home galaxy are two colossal, ghostly orbs of pure energy. They are called the Fermi bubbles, and they are a monument to a cataclysm we missed by millions of years. Discovered in 2010 by scientists analyzing data from the Fermi Gamma Ray Space Telescope, these structures are not made of stars or gas in the traditional sense. Instead, they are vast balloons of ultra-high-energy gamma-ray and X-ray emission, towering above and below the flat plane of the Milky Way. Each bubble stretches for 25,000 light-years from the galactic center, meaning the entire structure is 50,000 light-years tall. To grasp that scale, our entire solar system is a mere speck, orbiting about 26,000 light-years from that same center. These bubbles are so enormous that if our eyes could see their eerie gamma-ray glow, they would dominate a third of the night sky. Their discovery was a shock. The Milky Way's disk is familiar, but these towering, symmetrical lobes revealed that our galaxy's recent history was far more turbulent and energetic than anyone had suspected. They are the lingering aftermath of a titanic explosion, a belch of cosmic energy of almost incomprehensible power, but what could have created them? The prime suspect sits right at the launch point, the supermassive black hole anchoring the Milky Way, Sagittarius a star. While it is quiet today, astronomers theorize that several million years ago, it may have awakened in a spectacular feeding frenzy. As vast amounts of gas and dust spiraled into its gravitational maw, the black hole could have violently expelled a portion of that material in two opposing jets, shooting out from its poles at nearly the speed of light. These jets would have plowed through the galactic halo, heating gas and accelerating particles to extreme energies, inflating these giant, radioactive bubbles like a cosmic bellows. An alternative theory points not to the black hole but to a frenzy of stellar birth and death. In this scenario, the galactic center experienced a dramatic starburst episode where countless massive stars formed, lived brief, violent lives, and then exploded as supernova in a rapid chain reaction fireworks display. The combined shockwaves from hundreds or thousands of these stellar explosions could have blown a giant bipolar cavity in the surrounding gas, also creating the observed structures. The true answer likely involves a complex interplay of both forces. The Fermi bubbles stand as a permanent, high-energy scar, a testament to a time when the quiet heart of our galaxy roared with a violence that shaped its very structure. They are a reminder that even our familiar cosmic home has a wild and explosive past, written not in stone but in the silent, searing light of gamma rays. While the Fermi bubbles are a scar from a galactic-scale explosion, our next mystery is a whisper of physics gone subtly wrong, detected in the silent flight of two human-made explorers. As the Pioneer 10 and Pioneer 11 spacecraft completed their historic missions to Jupiter and Saturn, they began a lonely voyage into interstellar space. But scientists tracking their precise trajectories noticed something deeply unsettling. Both probes, hurtling away from the sun in opposite directions, were slowing down just a tiny bit more than they should have been. This was not the gentle tug of distant planets or the known push of solar radiation. It was an anomalous, constant deceleration, a tiny, persistent pullback toward the sun, equivalent to just 10 billionths of the gravity we feel on Earth's surface. For over a decade, this pioneer anomaly was a quiet thorn in the side of physics. The deviation was minuscule, but it was real, measurable, and utterly unexplained. In the precise world of orbital mechanics, where spacecraft navigation depends on knowing every force to an exquisite degree, an unknown force is a profound problem. The implications were staggering. Could this be evidence of a flaw in our understanding of gravity itself? Perhaps Einstein's theory of general relativity needed a tweak at the vast scales of the solar system. Some theorists even proposed it was a sign of unseen dark matter exerting a drag on the spacecraft, or a hint of entirely new physics lurking in the deep. The mystery captivated and frustrated scientists for years, a ghost in the machine of human exploration. The solution, when it finally came, was not a revolution in physics, but a masterpiece of meticulous engineering detective work. The culprit was not in the laws of the universe, but in the spacecraft themselves. The Pioneer probes were powered by radioactive thermoelectric generators which produced heat as a byproduct. This heat kept the spacecraft warm, and it had to radiate away into space. By painstakingly reconstructing decades-old blueprints and modeling the spacecraft's thermal properties, a team of researchers realized the heat was not radiating away evenly. The geometry of the probes meant more heat was emitted from the back of their dish-shaped antennae, pushing ever so slightly against their direction of travel. It was anisotropic thermal radiation, a tiny, lopsided photon thrust. Think of it like a car with one brake pad ever so slightly engaged, a force so small you would not feel it on a highway, but over a journey of billions of miles it becomes undeniable. The lesson of the Pioneer anomaly is profound. It taught us that in the quest to discover new laws of the cosmos, we must first become absolute masters of our own creations. Sometimes the universe is not whispering a secret, it is simply holding up a mirror to our own overlooked details, showing us that the path to deep truth often begins with checking our own instruments. That lesson in humility from our own spacecraft prepares us for a moment when the universe itself sent a visitor. In October 2017, astronomers in Hawaii detected a faint point of light moving at blistering speed. It was not orbiting the sun, it was passing through on a trajectory so extreme it could only have come from beyond our solar system. This was Oumuamua, a Hawaiian name meaning scout from the distant past, and it was the first confirmed interstellar object ever observed in our cosmic neighborhood. Its arrival was historic, but its behavior was utterly bizarre. As telescopes raced to track it, they revealed a profile unlike any asteroid or comet we had ever seen. First, there was its shape. Based on how its brightness changed dramatically as it tumbled, scientists deduced it was highly elongated, perhaps 10 times as long as it was wide. Imagine a cosmic cigar or a flattened pancake tumbling end over end through the void. Then there was what it lacked. As it approached the sun, it showed no visible coma, the fuzzy cloud of gas and dust that surrounds a comet's nucleus when ice is vaporized. It appeared dark and inert like a rocky asteroid, but then the final twist, its motion betrayed it. Precise measurements showed Oumuamua was not just coasting on gravity alone. As it sped away from the sun, it exhibited a tiny but definite extra push, a non-gravitational acceleration that could not be explained by the pull of planets or the sun. This is something comets do, as outgassing jets of vapor act like natural rocket engines. Yet no outgassing was ever detected, no tail, no coma, no gas signature in its spectrum. It was accelerating in silence. This paradox ignited a fierce scientific debate. One leading natural explanation proposes that Oumuamua is a fragment of a Pluto-like world from another star system, a chunk of solid nitrogen ice. As the sun's heat warmed it, the nitrogen would have sublimated directly from solid to gas, providing the silent thrust without leaving the dusty trail of a water-ice comet. Other ideas suggest it could be a dust aggregate, a cosmic dust bunny held together by weak forces, its lightness allowing radiation pressure from the sun itself to give it the mysterious push. But the combination of its strange shape, its silent acceleration, and its interstellar origin led some scientists, most notably Harvard's Avi Loeb, to float a more speculative possibility. Could it be artificial, a light sail, a piece of discarded technology from an alien civilization, using the pressure of starlight for propulsion? While most astronomers strongly favor a natural origin, citing the sheer abundance of material in the galaxy, the very fact that the hypothesis was seriously discussed underscores how truly anomalous Oumuamua was. It was a messenger that passed through our backyard too quickly for us to fully understand, a tumbling cipher from a star system we will never know. Its brief visit left us with more questions than answers, a permanent reminder that the galaxy is likely filled with strange, unseen travelers, and we have only just begun to notice them passing by. Oumuamua's silent passage hinted at unseen visitors from other stars, but there is a motion in the cosmos far grander and more unsettling than any solitary traveler. Entire clusters of galaxies, the largest gravitationally bound structures in the universe, appear to be caught in a mysterious river. Astronomers call this phenomenon dark flow, and it suggests we are being pulled by something that should not exist. This story begins with the oldest light we can see, the cosmic microwave background. This faint afterglow from the Big Bang is our ultimate cosmic reference frame, a snapshot of the infant universe. By studying tiny temperature variations in this light, scientists can measure how massive objects like galaxy clusters move through space. They look for a subtle effect where hot gas in a cluster scatters the SIMB photons, leaving a specific imprint that reveals the cluster's velocity. When a team analyzed data from hundreds of clusters, they found something astonishing. These colossal structures, scattered across billions of light-years, showed a coherent bulk motion. They were all streaming in the same direction at incredible speeds, roughly 2 million miles per hour, toward a point in the sky between the constellations Centaurus and Vela. This was not random. It was as if some immense, unseen force was tugging on them from beyond the edge of everything we know. The problem is, according to our standard model of cosmology, nothing should be able to do that. The gravitational pull of all the matter in the observable universe is already accounted for in these measurements. There is no known concentration of mass, no supercluster, no wall of galaxies, big enough or in the right place to explain this coordinated motion. It is a flow that seems to originate from outside our cosmic horizon. This is where the implications become staggering. One radical explanation is that dark flow is evidence of something tugging on our universe from the outside. Imagine our cosmos as a bubble floating in a vast multiverse. If another bubble universe passed close to ours in the higher dimensional bulk, its gravitational influence could, in theory, reach in and pull on the matter within our bubble. We would feel the tug, but the source would be forever invisible, lying beyond the limits of our own spacetime. The controversy around dark flow is intense. Some scientists question the statistical significance of the data or suggest unaccounted for systematic errors in the measurements. The original findings have been challenged and debated for years, a testament to how extraordinary the claim truly is. Yet, if confirmed, dark flow would be a crack in the door to a reality far larger than our own universe. It would mean the structures we call home are not drifting in isolation, but are part of a current flowing from a source we cannot see, drawn by a neighbor we may never meet. It is the ultimate cosmic tease, a hint that our entire observable universe might just be a leaf caught in a river whose banks lie in another reality entirely. This unsettling river of galaxies flows toward a mystery, but another lies frozen in the very first light of creation. Embedded in the faint, uniform glow of the cosmic microwave background is a chilling anomaly, a place that simply should not be there. It is called the cold spot, and it is a vast circular region of space that is significantly colder than the surrounding afterglow of the Big Bang. Discovered in 2004 in data from the Wilkinson Microwave Anisotropy Probe satellite and later confirmed by the Planck mission, this feature is not just a little cool. It is a profound statistical outlier, a cosmic bruise so large and so cold that its existence by standard models is less than 1 in 100. To understand why this is so strange, picture the early universe as a pot of nearly uniform, boiling water. As it expanded and cooled, tiny quantum fluctuations created slight variations in density, like bubbles of different sizes. These tiny ripples eventually grew under gravity to become the galaxies and voids we see today, and they left their imprint as minute temperature differences in the cosmic microwave background. The cold spot, however, is not a tiny ripple. It is a colossal, smooth depression in temperature, spanning a region of sky nearly 1 billion light-years across. It is as if someone took a giant, cosmic ice pack and pressed it against the infant universe. The leading natural explanation is that we are looking at a supervoid, an immense, nearly empty region of space between us and the cold spot. According to a concept called the integrated Sachs-Wolf effect, as light from the cosmic microwave background travels through such a vast, growing emptiness over billions of years, it loses a tiny bit of energy, making that patch of sky appear colder. The problem is, to explain the cold spot's profound chill, the void would need to be unimaginably vast and profoundly empty, far larger and emptier than any other void we have mapped. Surveys have found evidence of a large underdense region in that direction, but many scientists argue it is still not nearly substantial enough to account for the extreme temperature drop. The mismatch between the observed void and the required void leaves the door open for something far more spectacular. Some cosmologists have proposed that the cold spot could be a scar from a collision with another universe. In the theory of eternal inflation, our universe is one bubble in a frothing multiverse. If, during our universe's rapid inflationary expansion, it brushed against a neighboring bubble universe, the energy of that collision could have left a distinct circular imprint on our cosmic background radiation, a cosmic bruise from a long-ago encounter with another reality. While this idea is highly speculative, it highlights the sheer extremity of the anomaly. The cold spot remains one of the most tantalizing and debated features in all of cosmology. It is a fossil from the universe's first moments, a patch of cold that either points to a staggering emptiness in the cosmic web, or serves as a potential window into a cosmos vaster than we ever dreamed. It asks us a profound question: is the strangest thing in the universe a vast nothing, or the ghostly imprint of a neighbor we can never see? The cold spot confronts us with a profound emptiness, but the cosmos holds another, more fundamental kind of missing piece. This time, it is not exotic dark matter or energy, but the very ordinary stuff we are made of that has vanished. Astronomers call this the missing baryon problem, and it is a cosmic accounting error of epic proportions. Baryons are the particles that make up all the visible matter in the universe, the protons and neutrons in every atom of every star, planet, and person. Based on meticulous measurements of the early universe, specifically the cosmic microwave background, scientists can calculate with great precision how much of this ordinary matter should exist today. Yet, when they add up everything they can see, all the stars, galaxies, and glowing gas clouds, they come up staggeringly short. Over half of the baryons, the normal atoms that should be there, are simply missing. It is as if you meticulously budgeted for $100 but can only find 45 in your wallet, your bank account, and your pockets combined. The rest has vanished into thin air. The hunt for this missing matter has been one of the great detective stories in modern cosmology. the leading theory was elegant if difficult to prove. Scientists suspected the atoms were not truly gone, but simply hiding in plain sight. They predicted the majority of the universe's ordinary matter exists in the form of an incredibly diffuse, superheated gas. This gas is threaded along the filaments of the cosmic web, the vast, spider-like network of dark matter that connects galaxy clusters across the universe. These filaments are the highways of the cosmos, and the gas within them is so thin and so hot millions of degrees that it does not glow in visible light. It is essentially invisible to traditional telescopes. For years, this was just a compelling hypothesis. The evidence was tantalizingly out of reach. Then, astronomers found a brilliant new tool to illuminate the darkness: fast radio bursts. Remember those incredibly powerful, fleeting flashes from distant galaxies? Their journey to Earth holds the key. As a fast radio burst travels billions of light years through the cosmos, its radio waves interact with the sparse electrons in the intergalactic medium, the very gas in those cosmic web filaments. This interaction causes a slight, measurable dispersion, where different radio frequencies are slowed by different amounts. By analyzing this dispersion in the signal from a known distant burst, scientists can essentially count the number of electrons it passed through along its path. And since those electrons are tied to protons, the heart of baryonic matter, they can finally weigh the invisible gas. Recent studies using hundreds of fast radio bursts have done exactly that. The results are a monumental breakthrough. By mapping these signals from galaxies near and far, astronomers have finally been able to measure the density of the warm, hot intergalactic medium. The numbers are adding up. This diffuse, searing fog between the galaxies appears to contain the exact amount of missing matter predicted by the models. The case is not fully closed, as mapping the entire cosmic web in detail remains a colossal task, but the evidence is now overwhelming. The missing baryons were never truly lost. They were just too hot and too spread out for us to see, woven into the very fabric of the universe's largest structures. The mystery teaches us a profound lesson about our place in the cosmos. The dazzling stars and galaxies are merely the glittering knots in a grand tapestry. Most of the ordinary universe, the atoms that bind it all together, exists in the silent, scorching spaces in between. The universe's grand tapestry seems woven from chaos, but one pattern in its oldest light feels disturbingly familiar. Etched into the cosmic microwave background is a peculiar alignment that cosmologists have named, with a hint of dramatic irony, the axis of evil. This is not a malevolent force, but a statistical ghost, a set of large-scale patterns in the infant universe's temperature map that appear oddly correlated with the plane of our own solar system. To understand why this is so deeply unsettling, you must first grasp a foundational principle of modern cosmology: isotropy. On the largest scales, the universe should look the same in every direction. There should be no preferred axis, no special center, no cosmic up or down. The afterglow of the Big Bang should be a random, scrambled snapshot, its hot and cold spots distributed without any relation to our insignificant local neighborhood. The axis of evil suggests a violation of this sacred rule. When scientists overlay a map of the CMB with the ecliptic plane, the imaginary disk traced by Earth's orbit around the Sun, they find that some of the largest fluctuations in temperature seem to whisper an impossible connection to our own tiny corner of space. It is as if the universe's fingerprint somehow knows the orientation of our solar system, a correlation that should be statistically impossible across billions of light years. The implications are profound. Could this be evidence of some pre-Big Bang structure, a fossil imprint from a reality that existed before our own, that set a preferred direction for cosmic expansion? Perhaps it hints at a universe that is not perfectly isotropic, but has a subtle, woven-in grain like cosmic wood. The far more likely explanation, and the one most scientists favor, is a systematic error. It could be an artifact of how we subtract the foreground glow of our own galaxy's dust, or a subtle bias in the satellite instrumentation itself. Our view of the pristine cosmic background is filtered through the messy local environment of the Milky Way, and untangling that signal is a monumental challenge. Yet, despite rigorous checks, the anomaly stubbornly persists in the data from multiple spacecraft. It remains one of the most statistically tantalizing and philosophically troubling puzzles in cosmology. The axis of evil confronts us with a humbling possibility that the deepest map of all creation might still contain the faint, ghostly shadow of our own home. Even the universe's grandest mysteries can sometimes resolve into breathtaking beauty, a perfect geometry painted in the deepest red. Far from the statistical ghosts of the cosmic background, in the constellation Monoceros lies a celestial object so visually striking it seems almost designed. This is the Red Rectangle Nebula, a cosmic masterpiece surrounding the aging star HD 44179. Captured in stunning detail by the Hubble Space Telescope, its image defies the chaotic, cloud-like forms of most nebulae. Instead, it presents a near-perfect X-shape, a pair of intersecting ladder-like rungs set within a vivid rectangular glow, all blazing with the color of rust and embers. This is not a random cosmic cloud. It is a structure of startling precision, a work of art written in gas and dust. The vibrant red hue comes from a specific type of molecule known as polycyclic aromatic hydrocarbons. These are complex chains of carbon and hydrogen, essentially soot-like compounds that are being excited by the intense ultraviolet light from the central star. They fluoresce, glowing in that distinctive deep crimson, painting the entire structure in a single, dramatic shade. But the color, while stunning, is not the real mystery. The true puzzle is that extraordinary shape. How does the chaos of a dying star produce such geometric perfection? The answer lies in the delicate physics of stellar death. The central star is in a brief, volatile transition phase, shedding its outer layers into space. Crucially, it is not doing so evenly in all directions. Astronomers believe the star is surrounded by a thick, dense disk of dust, likely shaped like a giant cosmic donut which constricts the outflowing gas. This disk funnels the material into two powerful, opposing jets that shoot out from the star's poles above and below the dust plane. We are viewing this system nearly edge-on. From our perspective, the conical outflows from the top and bottom jets appear to form the two opposing sides of the X. The rungs or ladder steps within the structure are even more fascinating. They are thought to be caused by episodic bursts from the star. Instead of a smooth, constant wind, the star puffs out material in fits and starts. Each major pulse creates a new shell of gas that expands outward. As these successive shells are constricted by the central dust disk, they form the series of concentric, rectangular steps we see, like ripples in a cosmic pond frozen in time. The red rectangle is therefore a cosmic hourglass, but one viewed perfectly from the side, its sand made of glowing soot and its timer set by the rhythmic death throes of a star. It stands as a profound reminder that even in the violent act of stellar demise, the laws of physics can conspire to create structures of sublime, almost mathematical beauty. It shows us that the universe is not merely a place of random explosions, but also an artist capable of painting with perfect symmetry on a canvas of unimaginable scale. That breathtaking geometry in the red rectangle is a rare jewel in the cosmos, but the universe holds far more emptiness than it does art. Drifting through the constellation of Boötes, the herdsman, lies a region of space so profoundly desolate it has earned a chilling nickname, the Great Nothing. This is the Boötes Void, a spherical chasm in the cosmic web measuring a staggering 330 million light-years across. To grasp that scale, if you placed our Milky Way galaxy at its center, you would have to travel for over 150 million years at the speed of light in any direction before you would even begin to brush against its sparse, lonely edge. Within this incomprehensible volume, astronomers have catalogued only about 60 galaxies. In a similarly sized region of a typical part of the universe, you would expect to find thousands, perhaps tens of thousands of galaxies. Here, there is almost nothing. It is not a perfect vacuum, of course. There is still the thin, hot gas of the intergalactic medium and the pervasive influence of dark matter. But in terms of the shining cities of stars we call galaxies, it is a ghost town of cosmic proportions. How does such a vast emptiness come to be? It is a natural, though extreme, feature of the universe's large-scale structure. Picture the cosmos not as a uniform soup, but as a vast sponge or a cosmic web. After the Big Bang, slight density fluctuations were amplified by gravity over billions of years. Dense regions attracted more and more matter, collapsing into galaxy clusters and the long, thread-like filaments that connect them. The inevitable flip side of this clustering is the creation of corresponding voids, the empty bubbles in the cosmic foam where matter was siphoned away. The Boötes void is simply one of the largest and most underdense bubbles we have yet found. Its existence evokes a deep, primal sense of cosmic loneliness. If an advanced civilization existed on a planet within one of the void's few galaxies, their night sky would be almost unrecognizable to us. With no nearby galactic neighbors, their view of the universe would be dominated by an overwhelming inky blackness, punctuated only by the faint, distant smudges of the handful of other isolated island universes within the void. There would be no majestic band of the Milky Way, no great spiral of Andromeda looming large. Their entire cosmological perspective would be one of profound isolation. For us, looking in from the outside, the Boötes void serves as a humbling counterpoint. We live in a relatively crowded suburb of the universe, part of the local group, which is itself on the fringe of the massive Laniakea supercluster. The Great Nothing reminds us that our sparkling, galaxy-rich neighborhood is the exception, not the rule. Most of the universe's volume is empty, silent, and dark. It is the ultimate canvas of nothingness, a sobering glimpse into the true, vacant nature of the cosmos. That profound cosmic emptiness makes our own celestial neighborhood feel almost cozy by comparison. But what if something has been sharing that neighborhood with us all along, watching silently from the dark? For decades, a persistent legend has whispered through the fringes of space lore, the tale of the Black Knight satellite. This story claims that an alien object of unknown origin has been orbiting Earth for 13,000 years, a silent sentinel left by an ancient extraterrestrial civilization. The legend is woven from a patchwork of misunderstood events and creative interpretation, a perfect case study in how mystery is born from the gaps between fact and fiction. The myth often points to strange radio signals reportedly heard by Nikola Tesla in 1899 and later by Norwegian scientists in the 1920s, signals they speculated could be of extraterrestrial origin. But the visual cornerstone of the legend came much later. In 1998, during a Space Shuttle Endeavour mission to the International Space Station, astronauts captured footage of a dark, irregular object tumbling slowly against the backdrop of Earth. To the untrained eye, it looked eerily artificial and out of place, a perfect candidate for the fabled Black Knight. The reality, as is often the case, is far more mundane but no less fascinating. That iconic object was almost certainly a thermal blanket, a piece of multilayered insulation that had come loose during an earlier spacewalk. These blankets are essential for regulating temperature on spacecraft, but in the vacuum of space, once detached, they can twist and tumble in slow, silent ballet, reflecting sunlight in unpredictable ways. Their angular, crinkled appearance can easily be mistaken for something more structured and sinister. Other pieces of the Black Knight puzzle include misidentified images of early satellites like the Discoverer series, which had unusual, kite-like shapes, and even radar echoes from the 1960s that were later attributed to ordinary space debris. The U.S. Air Force itself once tracked an unknown object which they code-named the Black Knight, but it was concluded to be a fragment of a Discoverer satellite's protective casing. The legend persists because it taps into a deep and compelling narrative, the idea that we are not alone and that evidence of other intelligence has been hidden in plain sight, ignored or covered up by authorities. It transforms the chaotic, human-made clutter of our orbital backyard into something purposeful and ancient. The Black Knight satellite is not an alien artifact, but it is a cultural artifact, a modern myth born from our desire to find pattern and meaning in the unknown. It reminds us that as we reach into the cosmos, we often project our own hopes, fears, and stories onto the blank canvas of space, seeing monsters and messengers in the floating debris of our own ambition. Our myths of celestial monsters pale before the real, silent predator next door. The Andromeda Galaxy, that beautiful, faint smudge in our autumn sky, has a hidden history written in blood and stars. It is a cosmic cannibal, and the evidence of its past feasts is still scattered across its halo. When we look at Andromeda, we are not just seeing a serene spiral, we are gazing upon the aftermath of a violent, ongoing banquet. The proof lies in the faint, ghostly rivers of stars that swirl around it, far from its bright central disk. The most famous of these is the giant stellar stream, a vast, arching ribbon of stars that wraps around Andromeda like a torn stellar garland. This stream is not a natural part of a spiral galaxy's structure. It is the shredded remains of a smaller dwarf galaxy that ventured too close, perhaps billions of years ago. Andromeda's immense gravity, 1 trillion times the mass of our Sun, did not just capture this neighbor, it tore it apart. Over eons, the dwarf galaxy was stretched into a long, looping tidal stream, its stars scattered along the path of its final, doomed orbit. This is not an isolated event. Astronomers have identified several other distinct stellar streams and clusters within Andromeda's extended halo, each the fossil of a separate galactic meal. It is a galactic archaeology where the artifacts are not pottery shards but entire populations of stars, their motions and chemical compositions telling the story of their origin. This cannibalistic nature sets the stage for the ultimate galactic drama, a future collision written in the stars. Andromeda and our own Milky Way are on a direct course pulled together by their mutual gravity. In roughly 4 to 5 billion years, these two great spirals will begin a slow, majestic dance of destruction and creation. They will not simply crash like cars. Instead, they will pass through each other, their immense clouds of gas and dust colliding and triggering bursts of frantic new star birth. Their central supermassive black holes will eventually spiral together and merge. Over the course of billions of years, the two galaxies will lose their beautiful spiral shapes entirely, finally settling into a single, giant elliptical galaxy, which astronomers have already nicknamed Milkomda. This future is not speculation, it is a forecast based on precise measurements of Andromeda's motion toward us. We are living in a temporary peace, a calm before a storm of cosmic reconstruction. The cannibal galaxy is coming, and its final, greatest feast will be us. The cannibal galaxy's violent feast is a future certainty, but the universe is already forging jewels in unimaginable furnaces today. Among the thousands of exoplanets discovered, one stands out for its almost mythical composition. 55 Cancri E is a world believed to be made in large part of diamond. Orbiting a sun-like star 41 light-years away in the constellation Cancer, this planet is not a glittering gem floating serenely in space, but a vision of hellish opulence. It is a super-Earth, a term that belies its true nature, with a radius about twice that of our own world but a mass over 8 times greater. This extraordinary density is the first clue to its bizarre makeup. All that extra mass must come from something much heavier than the silicate rock and iron that form Earth. The leading theory points to carbon, and lots of it. In a solar system richer in carbon than in oxygen, the chemistry of planet formation shifts dramatically. Instead of forming rocky planets based on silicon and oxygen like Earth, the available carbon atoms can bind together under immense pressure to create crystalline structures. Scientists calculate that a significant portion of this planet's interior, perhaps up to a third of its entire mass, could be crystallized carbon diamond. The surface, however, is no place for a jewelry heist. 55 Cancri E orbits so close to its host star that 1 year lasts a mere 18 hours. The proximity creates tidal locking, meaning one side of the planet permanently faces the star in scorching daylight, while the other is locked in eternal night. Temperatures on the day side soar above 2,400 degrees Celsius, hot enough to melt iron and vaporize rock. Any diamond on the surface would not sit in neat crystalline beds, but would likely be part of a molten, seething landscape, a global lava ocean sparkling with suspended carbon crystals, shimmering like a cosmic inferno draped in glitter. The night side might be slightly cooler, but still unimaginably hostile, possibly featuring a solid crust of graphite and diamond mountains towering over plains of tar like hydrocarbons. This diamond planet challenges our very definition of a rocky world, proving that under the right stellar conditions, the building blocks of life, carbon, can forge a tomb of breathtaking, lethal beauty. A world of diamond is forged in stellar fire, but some of the universe's strangest creations are not solid at all. They are ghostly rings written in radio silence. In 2019, astronomers mapping the night sky with a revolutionary new radio telescope stumbled upon something that defied all expectation. Scattered across the cosmos were faint, perfect circles of radio emission, each one so vast it could encompass entire galaxies. They named them odd radio circles, or ORCS, and their discovery sent a quiet shockwave through the astronomical community. These are not the familiar, glowing rings of a planetary nebula or the chaotic blast wave of a supernova remnant. They are colossal, enigmatic halos, visible only to radio telescopes and utterly invisible in optical, infrared, or X-ray light. It is as if the universe has drawn faint, cosmic chalk circles on a blackboard only certain instruments can see. The sheer scale is breathtaking. A single ORC can span over 1 million light-years across, making it dozens of times wider than our entire Milky Way galaxy. Yet at the very heart of these immense rings, where you might expect to find a brilliant galaxy or a violent explosion, there is often nothing. Radio telescopes reveal the perfect circular glow, but when other instruments turn to look at the same spot, they see only empty darkness. This central emptiness is one of the deepest puzzles. What could possibly create such a gigantic, symmetrical structure without leaving a visible trace at its core? The hunt for an explanation is a process of elimination, and so far, every familiar suspect has been ruled out. They are not the remnants of stellar explosions in our own galaxy. Their size and distance place them far out in the intergalactic void. They do not match the profile of Einstein rings, where gravity bends light from a distant object into a circle. The leading natural theory points to a phenomenon of staggering power, the shock wave from a galactic wind. Imagine a galaxy undergoing a ferocious burst of star formation. Hundreds of thousands of supernovae explode in a relatively short time, their combined energy blasting a hurricane of charged particles out into intergalactic space. This outflow could create a spherical shockwave that expands for millions of years, and if we are viewing it from just the right angle, the edge of that immense bubble would appear to us as a crisp, circular ring. Another possibility is a titanic eruption from a supermassive black hole, a jet of energy so powerful it punches out into the cosmic medium, creating a similar expanding shell. Yet, even these dramatic explanations face challenges, primarily that central emptiness. If a visible galaxy is driving the shockwave, why can we not see it? Perhaps the galaxy is shrouded in unprecedented amounts of dust, hiding it from our optical sight. Or perhaps we are seeing the echo of an event that has long since faded, the ghost of a galactic catastrophe, its source now dark and quiet. The discovery of ORCS is a powerful reminder of how much of the universe remains hidden from our ordinary sight. For all our magnificent telescopes, we have been watching a silent movie of the cosmos, and only now are we beginning to hear its faintest whispers, whispers that trace out perfect million light-year-wide circles in the dark. That silent, ghostly geometry of odd radio circles speaks of immense but unseen forces, but sometimes the universe's violence is written in fire and motion for all to see. Zeta Ophiuchi is a stellar cannonball, a runaway star of breathtaking power and speed. If you could see it with the naked eye, it would be one of the brightest stars in the sky, a brilliant blue giant 20 times more massive than our Sun, and blazing with the light of 65,000 suns combined. But its true story is not in its brilliance, it is in its flight. This star is not orbiting peacefully in the galactic disk. It is screaming through space at an almost incomprehensible velocity, roughly 160,000 kilometers per hour, fast enough to travel from Earth to the Moon in less than 2.5 hours. As it plows through the galaxy, it does not move quietly. Like a speedboat tearing across a cosmic lake, it creates a magnificent, turbulent wake. The star emits a powerful stellar wind, a continuous supersonic stream of charged particles blowing from its surface. This wind slams headlong into the delicate clouds of interstellar gas and dust that fill the space between stars. The collision is violent and spectacular. The incoming material piles up, heats up, and glows, forming a vast, arcing wall of compressed and energized matter directly in front of the speeding star. This structure is called a bow shock, and for Zeta Ophiuchi, it is a cosmic masterpiece visible primarily in infrared light. In stunning images from telescopes like NASA's Spitzer Space Telescope, you see the star itself as a brilliant blue point, but ahead of it, sculpted into a perfect glowing arc, is a mammoth crescent of heated dust, a stellar wave frozen in space. The scale is humbling. This bow shock spans about half a light year from tip to tip. How did this star become such a celestial projectile? The most compelling explanation is a story of stellar betrayal and cataclysm. Astronomers believe Zeta Ophiuchi was not born alone. It likely began its life in a binary system, orbiting a companion star even more massive than itself. In the brutal life cycle of massive stars, the more massive one burns through its fuel faster. That companion would have reached the end of its life in a titanic supernova explosion. In that instant, the binary system's delicate gravitational balance was shattered. The exploding star would have suddenly lost most of its mass, its gravity vanishing in a flash. The remaining star, Zeta Ophiuchi, was suddenly freed like a stone released from a sling, and it was flung away at its tremendous orbital speed, now a runaway survivor of a stellar catastrophe. Today, it continues its lonely, high-speed journey, its brilliant bow shock a permanent testament to the explosive event that launched it. It is a reminder that the galaxy is not a static painting, but a dynamic arena of gravitational pinball, where stars can be sent careening across the darkness by the death throes of their closest companions. A stellar cannonball carves its path through the galaxy, but some cosmic messengers travel even faster and carry far stranger news. In September 2017, a ghost passed through the Earth. Deep within the pristine ice at the South Pole, the Ice Cube Neutrino Observatory, a colossal telescope made of a cubic kilometer of Antarctic ice threaded with thousands of sensitive light detectors, registered a tiny, profound shudder. A single, impossibly energetic particle had struck an atomic nucleus in the ice. This was no ordinary particle. It was a neutrino, trillions of which pass through your body every second without a trace. They are called ghost particles because they barely interact with anything, flying through planets and stars as if they were empty space. But this particular neutrino was special. It carried an energy over 200 times greater than the protons in the world's most powerful particle collider. The scientists, with a touch of whimsy, nicknamed it Big Bird. The detection alone was remarkable, but the real breakthrough was what happened next. Within seconds, ice cubes sent out an automated alert to observatories around the globe and in space. The alert contained a rough sky coordinate, a cosmic "look here." Astronomers swung their telescopes to that patch of sky, searching for any source that could have produced such a powerful ghost. Their search zeroed in on a brilliant, violent object 4 billion light-years away, a blazar known as TXS 0506+056. A blazar is the heart of an active galaxy where a supermassive black hole is feeding ravenously. As matter spirals into the black hole's maw, some of it is funneled into jets of plasma and radiation that shoot out from its poles at nearly the speed of light. We happen to be looking almost directly down the barrel of one of these jets, making it appear as an intensely bright and variable beacon across the universe. Follow-up observations confirmed a crucial link. At the exact same time the Big Bird neutrino arrived, the blazar was in a state of extreme flaring, emitting a huge surge of gamma rays. This was not a coincidence. It was a correlation that marked a revolution in how we see the cosmos. For the first time ever, scientists had traced a single high-energy neutrino back to its specific astrophysical source. This event, known as IC 170922A, is a landmark in the field of multi-messenger astronomy. Before this, we studied the universe primarily with light, from radio waves to gamma rays. Neutrinos and gravitational waves offer entirely new messengers. Neutrinos, in particular, come directly from the heart of the most violent processes, like those particle jets near black holes, because they can escape environments where light would be trapped. By combining the neutrino signal with the gamma ray and optical data, astronomers could piece together a far more complete picture of the blazar's explosive behavior. It was like hearing a distant explosion, seeing its flash, and for the first time, also feeling a piece of its shrapnel hit your hand. That single ghost particle, traveling for 4 billion years, delivered a message that confirmed these monstrous black hole jets are cosmic particle accelerators of almost unimaginable power, capable of hurling fundamental pieces of matter across the universe. It proved that to truly understand the cosmos, we must learn to listen with every sense we have, even to the whispers of ghosts. Those ghost particles carry messages from the most violent engines, but the Milky Way itself has a cannon capable of firing entire suns into the eternal dark. These are the hypervelocity stars, and they are the galaxy's ultimate escapees, traveling so fast they will never return. Unlike the runaway Zeta Ophiuchi, which was likely flung by a stellar explosion, these stars are believed to be the product of a far more monstrous gravitational machine, the supermassive black hole at the very heart of our galaxy, Sagittarius A star. Imagine a binary star system, two suns orbiting each other, drifting too close to that invisible titan. The black hole's immense gravity can violently tear the pair apart. One star gets captured into a tight, doomed orbit around the black hole, while the other is catapulted away at a staggering speed, often exceeding 1.5 million kilometers per hour. It is a perfect cosmic slingshot, a gravitational assist of terrifying power. Computer simulations of stellar dynamics near such black holes show this process in chilling detail, tracing the chaotic dance that ends with one star being swallowed or bound and the other flung out like a stone from a giant's hand. Once ejected, these hypervelocity stars embark on a solitary, one-way journey. They break free from the Milky Way's gravitational embrace entirely, destined to travel the immense, empty gulfs between galaxies. They become true interstellar nomads, solitary points of light sailing through a sea of nothingness. For any hypothetical planets orbiting such a star, the view would be one of profound and growing loneliness. The brilliant band of the Milky Way would shrink behind them into a faint, receding smudge, while ahead lies only the endless dark, punctuated by the distant, fuzzy glow of other island universes they will never reach. Their discovery tells us that our galaxy is not just a serene spiral of stars, but an active, dynamic engine that can, and does, fire its own components into the void. Each hypervelocity star is a permanent exile, a silent testament to a close encounter with the darkest heart of our home. Those stellar exiles are flung from the galactic core, but one star in our own cosmic backyard decided to stage a spectacular, self-destructive light show. Eta Carinae is not just a star, it is a cosmic catastrophe in slow motion, a hypergiant so massive and unstable it defies all expectations. Located a mere 7,500 light-years away in the constellation Carina, this is one of the most massive and luminous stars known in our galaxy, weighing in at over 100 times the mass of our Sun and shining with the power of 5 million suns combined. For centuries, it was a modestly bright point of light. Then, in the 1840s, it suddenly erupted in an event astronomers call the Great Eruption. Over the course of 2 decades, Eta Carinae brightened explosively, becoming the second brightest star in the entire night sky, outshone only by Sirius. It was a stellar tantrum of unimaginable scale, and it did not fade quietly. The star did not go supernova, it survived, but it blew off an enormous portion of its own outer layers, ejecting enough material to make 10 of our suns. That expelled material did not drift away as a shapeless cloud. Instead, it formed one of the most breathtaking structures ever imaged by the Hubble Space Telescope, the Homunculus Nebula. The name means little man in Latin, a reference to its shape as seen through early, less powerful telescopes. Hubble's view reveals it in its full, terrifying glory, a colossal bipolar nebula, 2 vast, opposing lobes of glowing gas and dust expanding outward from the central star at millions of kilometers per hour. It looks like a cosmic hourglass or a pair of screaming celestial lungs, lit from within by the ferocious radiation of the star it once shrouded. The nebula's delicate, lace-like structures and vast dust lanes are a forensic record of the eruption's violence frozen in time and space. Today, Eta Carinae remains a ticking time bomb. It is classified as a luminous blue variable, a rare class of stars in the final, feverish stages of their short lives, prone to giant outbursts as they struggle against the outward pressure of their own radiation. The star is wildly unstable, its brightness still fluctuating unpredictably. Astronomers know its days are numbered and its death will be spectacular. When it finally does go supernova, it could become as bright as the full moon in our sky, visible even in broad daylight. But the enduring mystery is not about its future, it is about its past. What triggered the Great Eruption in the 1840s? Why did it blow off such an immense shell without destroying itself completely? The leading theories grapple with the star's extreme nature. One suggests that the star's incredible luminosity reached a critical limit where the outward pressure of its own light rivaled the inward pull of its gravity, causing its outer layers to become so inflated and unstable that they were simply blown away in a series of massive pulses. Another, more dynamic idea involves a companion star. Eta Carinae is actually part of a binary system, with a smaller, hot companion orbiting it every 5.5 years in a highly elliptical, dramatic dance. Some models propose that during a close passage, the companion star could have plunged into the outer atmosphere of the hypergiant, triggering massive turbulence and ejecting the material. The precise mechanism remains one of stellar astrophysics' great puzzles. Eta Carinae and its beautiful, terrifying homunculus stand as a permanent monument to stellar instability, a reminder that the most brilliant lights in the cosmos often burn fastest and most violently, writing their final chapters across the sky in fire and dust. The violent brilliance of Eta Carinae defines one extreme of cosmic existence, but the universe holds a perfect, chilling opposite. Drifting in the quiet constellation Coma Berenices lies a ghost, a galaxy that should not exist. Catalogued as Dragonfly 44, this object is a cosmic paradox of terrifying scale. When astronomers first measured it, they received a profound shock. By observing the motions of its sparse, scattered stars, they calculated its mass. Dragonfly 44 is nearly as massive as our own Milky Way galaxy, a titan weighing in at around 1 trillion times the mass of our Sun. Yet, when they measured its light, the numbers did not match at all. This colossal galaxy emits only 1% of the light a normal galaxy of its mass should. It is as if you weighed a giant sequoia tree, only to discover it has the leaves and branches of a single, spindly sapling. The explanation for this impossible mismatch is both simple and profound. Dragonfly 44 is not made of stars and gas. It is made almost entirely of dark matter. This mysterious, invisible substance that makes up over 85% of the matter in the universe is not just present here, it is the galaxy's fundamental skeleton. The few stars that do exist, perhaps only one for every 100 stars in a galaxy like ours, are merely tiny, glittering ornaments hung on an immense, unseen framework of dark matter. They are like a handful of fireflies trapped inside a cathedral built of shadow. Deep sky images tell the story visually, where a normal spiral galaxy like Andromeda blazes with billions of concentrated stars, forming brilliant spiral arms and a glowing core. An ultra-diffuse galaxy like Dragonfly 44 appears as a faint, ethereal smudge. Its light is so dim and spread out that it evaded detection for decades, only coming into focus with the most sensitive modern telescopes. It is a whisper of starlight against the velvet black of space. The existence of such a galaxy poses a fundamental challenge to our theories of how galaxies form. We believe that galaxies begin their lives within halos of dark matter, whose gravity draws in normal gas. That gas then cools, condenses, and eventually ignites into stars. But in Dragonfly 44, that second step seems to have failed almost completely. For reasons we do not yet understand, the normal baryonic matter, the gas that should have become stars, either never collected in sufficient amounts or was somehow stripped away or prevented from cooling. What remains is a dark matter halo that never fulfilled its luminous potential, a galactic blueprint that was never built. This ghostly giant forces us to confront the raw, dominant power of dark matter. We often think of it as a mysterious add-on, an invisible glue holding visible galaxies together. But Dragonfly 44 shows us a reality where dark matter is not the support structure, it is the entire building. The stars are the afterthought. It reveals that the cosmos may be filled with these dark giants, invisible cities of shadow that outweigh the glittering metropolises we see. Their silent presence asks a haunting question about our own place in the universe. Are we the rule or are we the exception? Is the vibrant, star-filled Milky Way the standard model for a galaxy? Or are we living in a rare oasis of light within a cosmos dominated by darkness? A galaxy made of shadow reveals the invisible architecture of the cosmos, but sometimes the most intricate designs are carved in light and ice orbiting a distant sun. Far beyond our solar system, a world named J1407b presents a spectacle that makes Saturn's majestic rings look like a child's toy. This exoplanet, a gas giant likely several times more massive than Jupiter, is home to a ring system of such staggering scale it defies belief. If you could place this ring system within our own solar system, it would stretch from the Sun's position out past the orbit of Earth, engulfing the inner planets in a disk of countless icy and rocky fragments. The rings are not a uniform sheet but a complex layered structure with distinct bands and, most intriguingly, sharp, clean gaps. These gaps are not accidental. In our own Saturnian system, such clear lanes are carved out by the gravitational influence of embedded moons, shepherding the ring material and sweeping their orbits clean. The gaps in J1407b's rings strongly suggest the same process is at work there, hinting at the presence of exomoons in the very act of formation, sculpting their celestial cradle from the raw material of the disk. We have never seen a direct image of this ringed wonder. Its existence is known entirely through a breathtaking celestial shadow play. As the planet and its colossal rings pass in front of their host star, they block its light in a unique and dramatic signature. Astronomers observed the star J1407 dim not for hours but for an astonishing 56 days. During this nearly 2-month-long eclipse, the star's light did not fade smoothly. It flickered and dipped in a complex, jagged pattern, like a heartbeat monitor recording a series of cardiac events. Each dip and wobble in the light curve corresponded to different sections of the ring system: thick inner bands, sparse outer regions, and those telltale gaps passing in front of the star. It was as if scientists were reading a barcode written across the face of a sun, a barcode that decoded into a planetary system of majestic complexity. This method, called transit photometry, transforms a mere dip in starlight into a detailed map of a world we will never visually see. The sheer scale of this system forces us to rethink the drama of planetary birth. J1407b may represent a snapshot of a solar system in its extreme youth, a super Saturn caught in a fleeting phase where its rings are still vast and its moons are still coalescing from the debris. Alternatively, it could be the aftermath of a cataclysmic event, like a massive planetary collision that filled the sky with shattered remnants. Studying such a system, even indirectly, provides a crucial test for our theories of how all planets, including those in our own neighborhood, gather material and form satellites. It reveals that the processes we see in our solar system, moons forming from disks, gravity carving gaps, rings slowly spreading, are not local quirks. They are universal principles playing out on stages of unimaginable size around stars hundreds of light years away. This ringed giant, known only by the shadows it casts, offers a profound lesson. Sometimes the most detailed portrait of a distant world comes not from a brilliant photograph, but from the intricate pattern of a vanishing star, a silent eclipse that writes the story of moons being born in the dark. This shadow play of rings reveals the delicate artistry of cosmic construction, but the universe is also capable of pure, annihilating fury on a scale that dwarfs all else. The final event in our journey is not a puzzle or a phantom, but a definitive, apocalyptic fact. Gamma-ray bursts are the single most powerful explosions in the universe since the Big Bang itself. In a span of seconds, a single GRB can release more energy than our Sun will emit across its entire 10 billion-year lifetime. This is not a slow eruption or a gradual flare. It is a focused detonation of pure gamma-ray energy, the most lethal form of light. For a fleeting moment, a GRB can outshine every star in every galaxy in its observable universe. The source of this staggering power comes in two distinct, catastrophic flavors. The long-duration bursts, lasting from 2 seconds to several minutes, are believed to be the birth cries of black holes. They occur when a star dozens of times more massive than our Sun exhausts its fuel. Its core collapses instantly, not into a supernova but directly into a black hole. As material rains down onto this newborn singularity, part of it is funneled into two opposing jets of plasma and radiation that scream outward at over 99.99% the speed of light. If one of those jets is pointed like a cosmic rifle directly at Earth, we see it as a long gamma-ray burst, the final testament of a dying giant. The short-duration bursts, lasting less than 2 seconds, are even more violent in their origin. They are thought to be the death spirals of the densest objects in the universe, neutron stars. When two of these city-sized stellar corpses, each more massive than our Sun, finally merge after a billion-year gravitational dance, they can create either a new, heavier neutron star or yet another black hole. In that final, shattering collision, a similar but even more intense jet of energy is launched. These mergers are also the factories for the universe's heaviest elements, like gold and platinum, meaning the ring on your finger was forged in a gamma-ray burst billions of years ago. To visualize this, picture a lighthouse of pure destruction. The central engine, a hypernova collapse or a neutron star merger, acts as the bulb. The unimaginably powerful jets are the beams. But these beams are not broad and diffuse, they are pencil-thin, focused to within a few degrees. This is why we see so few of them. The beam must be pointed precisely at us to be detected. For any planet caught in the crosshairs of such a beam, the consequences are beyond catastrophic. If a nearby GRB within a few thousand light-years were to point at Earth, the effects would be an extinction-level event unlike any other. The initial blast of gamma rays would scour our atmosphere. It would rip apart ozone molecules, destroying the protective layer that shields life from the sun's ultraviolet radiation. The high-energy particles would then trigger a cascade of chemical reactions, generating nitrogen oxides that would rain down as corrosive acid rain and cloak the planet in a brown, smoggy haze, blocking sunlight and triggering a rapid global winter. This photochemical smog could persist for years, collapsing food chains and leading to a mass extinction. It is a sobering thought that such an event from a distant, anonymous star could reset the clock of life on our world. Fortunately, the universe is vast, and such perfectly aimed, nearby cataclysms are exceedingly rare. Our galaxy does not have many of the giant stars prone to producing long GRBs, and the merger events are even less common. Furthermore, astronomers have built a global sentinel network to watch for these flashes. Satellites like NASA's Swift and Fermi Gamma-Ray Space Telescope constantly monitor the sky, and within seconds of detecting a burst, they can alert ground-based telescopes to swing toward its afterglow, studying its fading light to learn its origin and distance. This early warning is our safeguard, a cosmic monitoring system that confirms these titanic explosions are, for now, distant spectacles. They are not threats but teachers. In their brief, universe-spanning flashes, they illuminate the most violent chapters of stellar life and death, reminding us of the raw, creative power that also, paradoxically, forges the very elements that make our world and us possible. They are the final, definitive exclamation point in the story of cosmic chaos, a reminder that from the greatest violence can come the seeds of new beginnings. From a single, forgotten whisper to the universe's most violent explosions, our journey has revealed a cosmos far stranger than any fiction. We have traced the ghostly paths of runaway stars and stood before galaxies woven from shadow. We have decoded eclipses written by rings wider than worlds and felt the silent tug of voids so vast they defy comprehension. Each of these 25 events, from the wow signal's fleeting hello to the diamond furnaces of distant suns, is a testament to a single, profound truth. The universe is not a static museum of known facts. It is a living laboratory of the bizarre, a frontier of endless mystery where every answered question reveals 10 more waiting in the dark. This is the real gift of astronomy. It is not about cataloging what we know, but about mapping the edges of our ignorance. Every anomalous signal, every inexplicable motion, every ghostly circle in the radio sky is a signpost pointing toward discoveries we have not yet dreamed of. The puzzles of dark matter and dark energy, the true nature of black holes, the potential for life in alien oceans, these are not the end of the story. They are the opening chapters of a narrative that will unfold for generations to come, written in the light of dying stars and the silent mathematics of gravity. So tonight, or any night when the sky is clear, take a moment to step outside, look up. In that vast darkness punctuated by pinpricks of ancient light, remember that you are not just looking at pretty stars. You are gazing into a cosmic detective story, a grand puzzle box of unimaginable scale. Every point of light could hold a secret, every dark patch could hide a wonder. Let that feeling of awe and curiosity be your guide. If these mysteries captivated you, consider subscribing to continue the journey with us. And we would love to hear from you. What was the most bizarre cosmic event that reshaped your view of the universe? Share your favorite in the comments below. The greatest discovery is that the adventure never ends, and the next great cosmic secret is waiting right now for someone to find.